Hi, how are you doing? So today I want to talk to you about one of the challenges posed by real-world datasets. Well, this challenge is called imbalanced data. What do I mean by imbalanced data? Well, we will go ahead and look at the definition of imbalanced data, and then we will take a look at what are some of the ways that we can deal with such imbalanced datasets. Okay, so in an ideal world, if you are trying to make a binary classifier, that means that you are trying to classify items into two bins. The training data will contain roughly equal number of rows for class A and class B. Okay. But this happens only in an ideal world. Most real-world datasets contain imbalanced data, which means that the number of rows of data belonging to class A will be very different from the number of rows of data that belong to class B. For example, we'll have 100,000 rows of data that belong to class A and just 10,000 rows of data that belong to class B. This is a highly imbalanced data set, and if you try to make a machine learning model with this imbalanced data, it's going to give you very wrong results. So how can you rebalance this data to make sure that your model kind of learns equally from both these both these classes of data? Well, one way to do this is to undersample from the more dominant class, right? So instead of using all 100,000 rows of data from class A, you randomly pick a subset of data and use that when you are building your model. The other approach is actually to oversample your less dominant class. This means you have to create extra rows of data for the class B or the less dominant class. How do you do this? Well, you can simply copy paste the data a bunch of times so that you are rebalancing the data, or you can use a more sophisticated algorithm like SMODE that creates more rows of synthetic data. And there's a third approach that is actually a mix of these two approaches. And the hybrid approach actually uses a little bit of undersampling from the more dominant class and a little bit of oversampling from the less dominant class. So now you might be wondering, hey, all this is really cool, but how can I actually write code that does all this? Well, fortunately, someone else has already written the code, and there is a fantastic package. The package is called Imbalanced-learn. And the good news is that Imbalanced-learn is pretty easy to install and use. And there's another piece of good news, which is that Imbalanced-learn goes hand in hand with scikit-learn. Scikit-learn, as you know, is the most popular machine learning package written in Python. So I really hope that you get a chance to install Imbalanced-learn from this website, and you get to download an imbalanced dataset, and then you can try using the different algorithms inside of Imbalanced-learn and see how they affect your model performance. Thanks so much, and see you in the next video.